So you have started to use already two methods, layer method and FMEA. Now, in this particular lecture, you are going to another method, QFD for PSS, right? QFD is complementary to FMEA. I am sure that at least some of you have learned QFD in product development course, and FMEA and QFD are complementary to each other, even in the PSS context. So, one challenge to be able to use QFD is to know what service is from the design point of view. You need to be able to design a service. Then, to do so, you need to have what are the characteristics, what are the parameters for a service. You will learn that. Then, a method, QFD for PSS. This is what you are going to learn. And in this lecture, I'm going to share with you a bigger method that involves QFD for PSS in it. Thereby, you can learn sort of broader framework or procedure to conduct improvement of PSS, right? So the what is the cornerstone? It's traditional QFD, quality function deployment, which was developed mainly for products and partly for service, but not for PSS. So that's what that's the gap. That was the gap that we filled. But just for a recap, QFD is based on the idea of market in, so taking in the customer's voices and translate them into design parameter so that the more important customer values are reflected on more important design parameters so that designers can focus their effort into those more important aspects. Was developed in Japan by some colleagues, for example, Professor Sakao, quite early, already 60 years ago. And thereafter, this method was disseminated all around the world. And it's recognized the usability, usefulness, and so on. Right? So let's dive into the question I mentioned at the beginning. So what are the service design parameters, service design characteristics? I think it's relatively more difficult than in the case of product design parameters, because a product is a physical one, and also you can touch and you can feel, you can see. Therefore, it's more easy to understand the parameters that belong to a given product. But let's think about what are the possible design parameters. In this slide, you will see 6 or 7 categories for such design parameters for a service. But this slide doesn't mean that these are the only categories, but there can be other categories. So don't limit yourself in seeing this slide. So let's start with responsiveness. As I said several times, when it comes to service, time is a crucial factor. And then how fast a service technician or service staff can respond to a given need is a relevant aspect. And a designer can decide how fast the service should respond to a given need. this is especially relevant when products have a sort of critical role in the customer's process and so on. So next, labor intensity. What it means is service can be supported by other components. For example, obviously products, but also software as well. And a given service can be described in terms of how much personal activity, human activity dominates the service, okay? And this has a big impact on the cost depending on the context, especially in Sweden and Europe. Labor cost is typically much higher than the cost for products, physical things, in many cases. Therefore, if the labor intensity becomes higher, the service cost tends to be higher. So therefore, it's relevant, and a designer can decide this. You will see the how the labor intensity can be adjusted or adapted in the next lecture, dealing with the product-service interdependency. Right? That's about the next lecture. But next one, customizability. I hope you remember that I mentioned the characteristics of the quality of service. There I explained that service quality should accept the variety depending on the customer needs, specific customer needs. Which means that service is expected to be customized and even tailor-made depending on the customer's needs. But earlier, I also mentioned that standardization is important to make the service economically viable. So there should be a middle point in between. That's why this customizability is an important aspect. A designer should decide how much customization a service should allow. A company providing services could provide sort of a very, very individual, tailor-made services for each single customer. But if they do that, it becomes maybe too costly. Therefore, such a service provider can and perhaps should limit the level of customizability. Affordability is very much related to what I already explained. It's related to cost, how much cost and price is associated to the given service. And security, it's related to information sharing and also information integrity, because service tends to exchange information between the customer and the provider, and this aspect can be very important. And designers should take this aspect into account. Reliability, we already discussed the possible uncertainty and risk caused by the uncertainty, and the reliability can be set for service at hand, okay, by different means. So that's what this means. Modularity, how much a given part of the service can be modular so that different modules can be combined or exchanged to a given need. Okay, so these are examples of the service category, service design parameter categories. And do you have any question for any of these? Or the idea of service design parameter, service characteristics? Yes, please.
How is the customization and modularity different from each other?
Difference between so the question is the difference between the customizability and modularity. They are related, and so the difference is, I think, from the difference lies in the perspective. The customizability is, as I said, how much it's possible to sort of change the degree of variety of a given service. Then modularity is more of a configuration point of view. So let's say there are different, let's assume there are different service, there are modules that are possible to be used for a given service. In order for that to happen, service must be modular to start with. So I hope it's clearer now. Okay. Any more question? Then do you think of any other service design parameter category? There can be others. Okay, this is probably the question that you can think of in your project work. Okay. So now I'm going to start with the broader procedure that I mentioned, which includes QFD for PSS in it. And I just want to introduce how my group, our group, together with my colleagues, developed this procedure. So we started to observe the need for such a method that can handle a product service system, not only product alone, but I mean not only product alone or service alone, but such a method addresses product and services in the system both. And then we started with theoretical exploration, what could be such a method. And then we came up a proof of concept, POC, for such a method. Let's say 17 years ago. And then we tested the POC with a company based in Germany. The application will be explained in this lecture very soon. And then after the application, then we validated the method, and then we introduced the validated method into a different company which is also manufacturing complex products and providing services, and then we helped the company implement the method within their existing workflows, so that the outcome of their PSS offerings be better. Okay, so this is a sort of overview of the history of the research that we went through. So you know that the method or procedure that you are going to learn in this lecture and also in the other lectures are sort of validated from industrial point of view. So we call the procedure SPIPS, and it starts with analysis of customers, step 0 on the left-hand side, and step 1 at the top. You may want to segment different customers. and extract customer values, or sometimes customers' cost or customers' risks as well. And as I added here, customer activity cycle, CAC, this is what I assume you have already done. Right? You, at least to some extent, analyzed the customers that you are considering, and you extracted customer values. Right? And here, one step that you can add is sort of a quantitative analysis of the set of customer values. That can be done using this 2x2 matrix. This is quite popular in industry because in industry, always the resource is limited. They want to focus on more important ones and more feasible ones. And so let's say you have multiple customer values that you are considering, okay? And each customer value can be assessed in terms of 2 dimensions. Number one, importance for the customers, okay? The other dimension is the level of current satisfaction of the customers. So apologies for the colors of the font for the 2 dimensions are hard to see, but what I said is written on the slide. So on the horizontal axis, less important on the left-hand side, more important on the right-hand side, okay? And for the vertical axis, more satisfied currently is for the upper half, and less satisfied is the lower half of the matrix. So then you see 4 different areas, right? And so for example, in the, let's say, in the left bottom area, less important, and even though the current customers are not so satisfied, but it's less important, then probably we shouldn't focus so much on the left bottom area. And if you go to the more important, and also the customers are relatively more satisfied with, then maybe we can just continue. Huh? And probably the most interesting area is the right bottom. So that means the given customer value on the right bottom corner is more important, but customers are currently not so satisfied. Okay, so important, but not yet not so satisfied. Then this gives an opportunity for improvement. Okay, so in order to so you are expected to collect the data for the 2 dimensions, and then plot all the customer values on this 2x2 matrix, and then you will get the results. Okay, so these customer values are the what we should focus on for the improvement. Okay, so by going through this exercise, you can have more focused investment for the improvement, and the outcome of such exercise can be input to step 4. Huh? Step 4, this is where QFD can be applied. The purpose is translating the customer values into design parameters. Okay? And so QFD for PSS can consist of 2 phases. The first phase is correlating the customer values on the left-hand side you see, and the characteristics of products or characteristics of services at the top of the matrix on the left-hand side. Okay, so in the matrix you give differentiation in terms of the correlational strengths between a given customer value and characteristics. Right? And of course, the difference with the traditional QFD here is we need to have design parameters for the services here in the matrix. Okay? Without that, it is very similar, almost identical to the traditional product design QFD. Huh? So, so the new feature of QFD for PSS lies in the blue shaded parts, okay, of the matrix. And phase 2 aims to correlate the design characteristics and the components of the product and services. Any question for this? If you know traditional QFD, then I think you will be rather easily understand. Huh? So the extension is the addition of the service aspect. Okay, and as I said at the beginning, you can use the service design parameter categories when you describe the service design parameters here. Okay. Obviously, when you handle a specific PSS, then the service design parameters also must be specific. Okay. But I'm sure that you understand that. Okay. Then another new feature probably is how to describe components of services. Huh? In the case of components of products, it's, I think, easier. For example, one component of passenger car is an engine, right? Tires. So those are physical components, no? Physical entities. But then what is then such entities for a given service? It can be different ways of describing such components for a service. But one of our papers suggests that components of a service may be human resources, information, or service tools. So the important point here is we want to describe an entity for a service, which is different from a characteristic. Okay? A characteristic is a parameter which has a dimension, a unit, but component is yeah, an entity. I hope I'm making a clear distinction between the components and characteristics. Okay. So by looking at examples for each category, I think you will better understand. For example, service technician. This belongs to a human resource category. Okay. This is an entity required for a given service, huh? And online support staff, and so on. Information is another type of a component. Service manual, information for the product usage history, database, that belongs to the information. And service tools could be, for example, repair tools, physical tools, and it can be analytic, data analytic software. Of course, these are the sort of abstract categories, and then if you if you conduct phase 2 of QFD for PSS, then you need to concretely describe the components for service at hand. Okay. Any question? Oh, yes. Yeah.
Is there any commonality between the components of the products and service components?
So the question is there any commonality between the components of products and components of service? Commonality is I think, once again, excuse me for using the term entity. I think that is an overarching concept. It's an entity that is a part of a product. Is, for example, engine in the case of passenger car, no? And that applies to the service as well. So let's say maintenance service. There must be a maintenance technician. That's one entity. And a maintenance technician usually brings some toolkit. That's another entity. So I hope I answered your question. Okay, good, thank you. And then you.
Give an example of characteristic of a service to help draw contrast between component and characteristic.
Give an example for this.
Characteristic of service.
Okay, this one.
Compare with the component of service.
Okay, yeah. So, and then let's go back to the examples of this. No? Okay, let's see. Okay, let's take this as an example. Responsiveness, repair service. So we think of repair service as an example, and a designer should decide how responsive the service should be. Huh? And as we discussed, entities required for the maintenance service can be maintenance technician and maintenance toolkit, information, and so on. So responsiveness is one aspect that can be measured and also that can be controlled by a designer. But then service components exist on a different dimension that are entities. Right? So each entity can be also somehow measured from the responsiveness point of view. So is it clear now? Okay. So the other examples are also such that these characteristics are parameters and the components are entities. Huh? Okay. More question? Yes, please.
For the benefit of all, so
Do you want to use microphone? Or? No. Okay. No. Go ahead. Oh, thanks.
so this question is for the benefit of all. Yeah, so this question is for the benefit of all. While identifying the service characteristics in QFD, so you have specifically talked about three ways that you can think. One is the human resource, other is the information, then comes the service tools. Now I'm giving a situation that, okay, I buy a Toyota car and the car manufacturer tells me to install their app in my mobile, through which they are actually maintaining a customer relationship with me. And all my service requirements they want me to do through that particular app. So when I talk about this app, in which category you think that it will fall into? Information and service tools. Because I see the moment I talk about that particular app, it will also have the information characteristics. It will also have the service tools.
Yeah.
So what is your take on this?
Yeah, I would say the such an app is primarily a kind of service tool. But what is a bit complicated is such an app uses information typically. And then that information should be the type 2. No?
Okay. So maybe when we actually try to put it in the QFD, so maybe we should be able to disintegrate the features of the app itself and then start discovering the information and the service tool aspect of it. But as a whole, the app would come under service tools.
Yeah. Yeah.
Thank you.
Yes. Thank you, Pratul, for your question. One important thing to be conveyed to you is the order of addressing the characteristics and the components. The characteristics are addressed first before the components are addressed, because the characteristics are closer to the requirements, okay? And these are more abstract, okay? Depending on, for example, responsiveness is one of the service design parameter category, okay? Depending on the designer's decision on how responsible the service should be, required components for a service are different. No? So if the service designer wants to make the service very responsive, very fast response, then they require perhaps service tools like connectivity and analytics and so on. So this is, I think, one important message taken from this QFD procedure. So the order is not at random, it's rather deliberately chosen. No? Okay, good. And one example for QFD for PSS phase 1 may look like this. The customer value could be, in this case, was used for the grass cutter and the related services. Customer value could be easiness to understand how to use the product, small space to store, easiness to set up, variety of cutting modes, short time to trim, uniformity of trimming, availability, convenience at the end of use, the cost of accessing to trimming. Do these make sense as customer value? No? So once again, be reminded that these are from the customer's point of view, and each of these should be shouldn't assume any solution. Right? And then going to the characteristics, product characteristics could be size of the trimmer, weight, mean time between failures, modularity of the product, speed of cutting, stability, physical stability, and product manual. So these are the, well, I would say the availability of the product manual, to be precise. No? When it comes to service characteristics, here, quality of information provided. For example, how detailed should be, and so on. Quantity of information provided. For example, it shouldn't be too many pages in manual and so on. Calendar time of response to inquiry. This is exactly a kind of responsiveness. No? Calendar time of maintenance, variety of services provided. This belongs to the customizability service design parameter class. No? Quality of service manual. Do the characteristics make sense? No. And as in the original QFD, the matrix should receive the numbers 0, 1, 3, or 9 to differentiate the level of correlational strength between each customer value and a characteristic. No? And the calculation is the same from the traditional QFD. You will multiply together with the weighting for the customer value. You have access to a spreadsheet file that has already implemented the calculation formula here. So it's straightforward if you look at the calculation formula on that Microsoft Excel file. Any question related to this example? Okay, great. And the outcome of such QFD exercise is design focus, or FODC. And you should use such focuses, or FODC, for the brainstormings related to improvement. It's a designer's creative activity. Then outcome is possible solutions. Okay. And then step 6, you need to make sure that the derived improvement is economically viable, for example. And in that case, you may want to use life cycle costing, for example, or another assessment tool. Okay. And in that step, last step, you may want to also use the similar 2x2 matrix. Again, apology for the color of the font for the dimensions. So in this matrix, the horizontal axis is for the degree of improvement in terms of customer value, low, high, okay? And vertical axis is the amount of necessary investment, okay? High and low. So by using this 2x2 matrix, you can easily get support for rational decision making, right? It's obvious, no? These four spaces mean. Okay, good. Any questions so far? Good. Then I will explain to you the application case where I together worked with a company based in Germany, and we came up with some design solutions by applying this SPIPS procedure. So to start with the case, a small background of this company and their business. It's a manufacturer producing rather large-scaled products, complex products that need quite a high investment. It's not a cheap one, so the product is rather expensive. And well, typically the machine is computer controlled, and the availability is critical. So this is the sort of important feature for the product. And interesting thing is, at the time of the collaboration, the company had implemented the sort of infrastructure for digitization and also communication, information transmission, and also some sort of analysis. And the motivation of the company was to make sort of balanced investment between physical products and also services. So this is exactly, I think, a typical situation where the company benefits from product service system design. Okay? We started with a survey of the customer value. I mean, obviously, before asking potential and existing customers, we did analyze what are the customer values, customer needs. You know, do you remember the step 0 and 1 of SPIPS? So you are supposed to analyze the customers and analyze what their needs and what their wants are. And then we came up with, after that, we came up with about 12 customer value items. And then we did a survey using those 12 customer values. We asked the customers to rate between 1 and 7 for each customer value. And the result looks like this. So the most important customer value was quality of the final product. Final product means the product produced by the investment machine. So not the invest machine itself, but the outcome of the product produced by the focal company. Immediate availability. So as I said, the machine is time critical. So the customer finds immediate availability is highly important. And available operation time in terms of calendar. So these were the top 3 customer values. So then what the next step or the step 4 of SPIPS is, as I explained earlier, translating those customer values into characteristics of products and services. So as you see here, these are the top 3 customer values, and the numbers are given for the customer values. The numbers that you saw on the previous slide, the highest one is 6.8 and the lowest one is 4.8. So these numbers were input to differentiate the relative importance. And then here, product design characteristics and also service design characteristics are listed in the matrix, and then QFD table were given here, correlational matrix. Thereby, as an outcome, the relative importance of the design characteristics, right? So in this application, we used specific software. It's not a commercial one, developed by for academic purpose. And then we saw as an outcome from the software, we saw relative importance of design characteristics. So using the outcome, designers did brainstorming by looking at what improvement options can be possible to improve the more important design parameters. And it's up to the designers, and it's when this method, SPIPS, is applied in industry, then this specific part is depending on the capacity of the designers, and it's not really controllable. But anyway, in this specific case, the designers came up with these solutions. For example, number 1, machine end operation with less frequent malfunction, meaning that it mainly responded to the immediate availability, which was second most important customer value. And then they came up with a solution. Both the product and the service should be less frequent malfunction. And another example is stuffs with quick response. This also contributed to the immediate availability and also available operation time for the product. So just observe that these suggested solutions were based on the outcome of the QFD exercise, which uses the customer survey results. So the now you understand the workflow of the SPIPs helps designers to find important design space consisting of important design parameters so that the derived solutions are really targeting the important customer values. Okay, so any question regarding the case? Okay, so I can give some highlights for this method called SPIPs. I think it's quite obvious that this can be applied to early stages and addressing both products and services, and the procedure as such is a sort of modular, meaning that some steps could be omitted. For example, performance importance matrix could be omitted, for example. So in that way, you can choose which steps you will conduct depending on the resource that is available. Okay. Any question regarding the workflow SPIPs that includes QFD? Okay, good. I just want to introduce another application case. We applied sort of several variants of QFD for PSS in different contexts. This is one such case and published in a paper. In this case, we included environmental aspects as a requirement so that the solutions suggested were also environmentally conscious. And then we compared the status quo versus the derived improved solution in terms of life cycle CO2 emission. So in this case, we compared the starting point and the ending point of using the method in terms of the environmental aspect. Another case is taken from another research group. They use a variant, again, another variant of QFD. E stands for environment, QFD for environment. It's a variant of QFD. So the message here is the outputs of QFDE were effectively used for the SWOT analysis, which is very popular in industry, and supporting strategic decisions of a given organization. And so, I mean, as you know, the SWOT analysis, the outcome of QFDE can be easily integrated into the SWOT analysis. And in this case, they even applied a similar analysis called TOES. So with this example, I wanted to share with you QFD variants. QFD for PSS is one of them. Can be combined with other methods, which include strategic decision support tool, and so on. So in that sense, it's quite modular. QFD as such is modular. So meaning that it can be embedded in a certain workflow and another workflow and so on. With that, I'm happy to take further questions from you. Hi, so just for clarification, you have access to one Excel file, which consists of 2 sheets at least. One sheet is for phase 1, the other is phase 2. And phase 1 sheet looks like this. So you type in the customer values for your own PSS and put numbers for the customer values and type in characteristics of product and services and put numbers in the matrix, and then you will get the relative importance of the design characteristics as a result, right? And phase 2 is for the components added, but probably due to the time limitation, our suggestion is to focus on phase 1. Okay? We think that is enough for using your learning outcomes with the hands-on exercise. Okay? Good. Thank you for your attention. the study. This may sound very stupid, but this is how it is. We hear from time to time an accident happened. Just a few hours ago, I read an article on the helicopter and aircraft crash in US. It happens. And this study showed that in the service business, the majority of the situations include unrealized service. This study didn't focus on PSS, but thinking about all of what you learned in this course so far, product service are interrelated, and making sure the interrelation between the product services are fully utilized is very important in PSS design. So this big portion of failures indicates that such a importance of seeing the connections, interrelations between the product and services in a system. Okay, did it make sense? So that was an introduction, and so now the question is, we need to find such an interdependency between a product and a service in the system that you are looking at. And once you find such an interdependency, then I'm recommending you to use the exchangeability. This is the term that we developed, we coined. The definition of the exchangeability is a feature of being able to exchange efforts for service and physical product design to improve the overall PSS characteristics independent, interdependent products and service. You have seen this tree structure in the lecture of FMEA. So the same kind of tree structure is what you're looking at, and these small circles represent functions realized by either service activity or a physical component. But the aim of these functions is to realize a certain customer value. No? Right. So look at the relation described here. So that part shows that a certain function, a small white circle, is realized by the service activity or the physical component. And if this relation exists, we say that the efforts for the service activity or physical component can be exchanged. And we say that there is an exchangeability. It's a little bit abstract statement and discussion, so I will give you the most simple, I would say, example. So service and product, right? And both of these can serve a certain customer value. For example, a customer, let's say, wants some information to answer his or her question, okay? And then that customer value can be met either you as a provider providing a help desk service, or for example, some kind of manual. It's a product, right? So both of these can be a measure for that customer, to meet that customer value. And here, you as a designer can choose which one you adopt in your PSS. Okay? And in some cases, you may want to choose both. And depending on a specific situation, you will choose. So that's also possible. The choice can be determined in terms of several aspects. One could be the economic viability of you as a provider. So you may want to choose the option that is most cheapest one, or you may want to use the degree of customer value as a choice criterion. So you may want, then in that case, you will choose the option that provides the highest customer value. So here, you can choose in between different options. So that's what exchangeability means, okay? And from now, I am giving you 11 examples. Each example shows such an interdependency and also implying exchangeability between products and services, okay? So the first example is from washing machine, and those examples are all taken from scientific papers and building upon industrial cases, okay? So, according to a certain research work, a washing machine was used in the PSS context, and the washing machine was redesigned for an easier repair. So this is an example I think we have touched upon in the course so far. And we see dependencies. Product, in the case, the washing machine depends on the service, in this case, repair. And the repair performance depends on the product design. So therefore, the direction of the dependency is bidirectional, okay? And earlier we discussed product design parameter categories, service design parameter categories, and in this case, we can see the service design parameter belonging to labor intensity, one of the service design parameter categories. And in this case, the relevant product design parameter category is serviceability of the washing machine. And by addressing a balance between the two, you can contribute to increase the resource efficiency. So that's the aspect. Did you follow? I will use exactly the same scheme in the upcoming examples. So you see, first I will show you the sector and then the very brief description of the example, and then I will use this scheme. And I'm sure that you will get even more familiar along the examples. So another case, pump. In this case, it's interesting that specific services, in some cases, require specialists, not ordinary staff in the service, but service specialists. And in this case, and also, the product needs to be serviceable, and depending on the depending on the personnel who executes the service, the product design must be ready for the service to be executed. For example, if if a product is designed in such a way that every user can inspect and repair and so on, then capability required for the services is low, for example. No? One example is like exchanging batteries. That can be done every layperson. And so the capability of the service technicians depends on the serviceability of the product, right? And in this case, making a good balance between the two contributes to the product service system design parameter availability, right? Okay. Continuing with the same product, serviceability of the product again influences on the responsiveness of the service, in this case actual service time, which we discussed earlier, responsiveness. So the responsiveness depends on the serviceability of the product, so that the availability could be improved. Right? Next case from construction machine. The product design, in this case, the research work addressed the specification for the hydraulic system of the construction machine. That specification for the product design depends on the information coming from the service execution. Next case, jet engines in aerospace. It's quite simple. Cost of overhaul, that is a service activity, depends on product design, so that the overall cost can be influenced. Vacuum pump, again, service cost against product cost can be handled so that the overall affordability or the price can be influenced. In the case of forklift truck, labor cost of the service technicians can depend on the product design, and in this case, automatic monitoring device was considered to be put into the forklift so that the service labor cost will be decreased. No? Affordability. Next example, again construction machine. The maintenance task depends on the information transferred from the product design. Availability. And the next example, again, jet engines and aerospace. Product design depends on the information from the information that can be obtained from the service activities. In this case, deterioration. So the in this case, product design products were upgraded in terms of design depending on the deterioration. I mean the product condition from the that can be obtained from the services. Right? So two more examples. Medical equipment case. In this case, the devices, when the medical equipment devices get older, then there was a need of more education of the technicians, hospital technicians and doctors in terms of training in order to increase the knowledge, their knowledge for how to deal with the medical equipment device. So therefore, and also, sorry, in this case, they found that better training, better education on the service technicians increased the product condition maintenance in terms of maintenance. Last example, which I already told in earlier, soil compactor used in the road construction typically. The product was changed in that case in terms of the product surface, and therefore the deterioration of the surface of the product influenced the speed of the deterioration, influenced on the frequency of the services. So because they changed the soil compactor surface, therefore the frequency of the service was prolonged, and thereby the product life extension was realized. Okay, so I'm quite sure that you see this kind of interdependency between products and services in your own PSS case. And so here, what you should do is to find such interdependence and consider the possibility of exchangeability. So meaning that if only a product is used, then consider service to be implemented to replace the product component, okay? To realize the same customer value, and the other way around as well. If you have both product components and also service activities, then consider improving the balance of the efforts put into the product components. And so those are the things that you should consider in improving the product service system. No? Okay. So far, is it clear? Okay, good. And so now the question is, you have a product service system, and you have described product design parameters and service design parameters. The question is, which design parameters have interdependencies in between product and services? Because there are interdependencies, as I have been through different examples, but not all design parameters have dependencies from the other side. So in this picture, the red lines show the existence of dependencies between product side and service side, okay? And there are many parameters without the red line. And it's very time consuming if you need to check each and every design parameter from the product side and also same from the service side. It's very time consuming, right? And you need to consider every single time. So that's why a recommendation here is to lift up your thinking level from the instance level to the class level. So you move yourself up to the abstract level where the service design parameters and product design parameters are possible to represent as class parameters, categories. Now you can decrease significantly the number of parameters you can think of, because I exemplified earlier the service design parameter classes. Okay, in that particular slide, there were only 7 or so. Okay, and in the same way, product design parameters are not that many if you are on the class level. Okay, so therefore, the number of combinations can be significantly reduced. So the computational effort or analysis effort is much, much more lower if you do it on the class level, right? So what we have developed and you have access to is this matrix. This is built upon 42 cases that were reported in literature, and then this matrix tells you there are some interdependencies between the product design parameter classes and service design parameter classes. These gray cells mean that we haven't found a dependency between the combination. No? And on the other hand, white cells mean that at least one scientific work has found such an interdependency. Right? If you look at the service design classes, 7 classes, these are maybe a little bit modified from the slide that I showed you earlier, but more or less the same. For example, responsiveness, service technician capability, labor intensity, frequency, and so on. And for the product design parameter classes, here recommended are serviceability, affordability, information transferability, upgradability, and temporal functionality. And in the matrix, you see the direction of the dependencies. In the previous 11 examples, you saw the direction of the dependency with the arrows, no? With the direction of arrows. But here it's indicated by PUS, PBS, or SUP. It's a matter of representation. The same information is conveyed. Okay? And one more aspect shown on this matrix is the PSS parameter, PSS design parameter classes are also shown in the matrix. Okay, so you have access to an Excel file that shows exactly this matrix as well as the 42 cases that were the base to come up with this abstraction. Okay, and your task in the project work is to look into this and utilize some of these interdependencies. Huh? Any questions? Do you have questions? Yes, please.
Sir, so if you are developing service parameters, then there is a big component of unrealization. There are many things which can't be realized beforehand. So that makes it very experimental by nature. That we have to experiment and find what unrealized aspects are there. And sir, on the other hand, thank you. And sir, on the other hand, you showed that after the slides regarding design fixation and versus design limitations,
Yep.
there was a slide where it showed that most of the time was spent on problem space development
Yep.
and within that system development.
Yep.
Then sir, if system is unrealized, how can we spend most of the time in system? We have to develop the product, bring it to the market, and then like the graph for US product development where it was a spike after the product
Yeah.
was developed. It
Okay.
would be like that only if we like follow the route.
Yeah. There were many aspects coming from the earlier part of the course, and I can provide you with some additional information as answers. So let's take the picture of front-loading example, the failures happening after the launch of the offering. All of these methods and tools and support are meant to help designers to decrease that, preferably eliminate such a failure that occurs after product launch or PSS launch on the market. Okay, what's the rationale? Because this sort of knowledge base can help designers simulate what will happen when PSS is offered and when customers are involved in getting the results from the PSS offering. Okay, so that's one thing. So did you see the connection between this one particularly and the failures happening after the market launch? Okay, that's number one. And unrealized one, which I mentioned at the beginning of this lecture. So with this matrix, what unrealized service means is, let's say, okay, let's say there is a PSS, and the product used in the PSS has an important feature that is information transferability. For example, the product was expected to show some information. I don't know, product condition, for example, battery, power left, or things like that. This matrix shows that has a dependency to 3 service design parameter classes. For example, labor intensity and others. And then let's say a service technician is given an instruction from his or her own company, service provider, okay? And they have limitation in work hours or work effort, whatever. Right? And if this knowledge base is well used in design stage, and if this information transferability of the product and labor intensity was well integrated, then the service technician can fulfill the job effectively. But if that interdependency was not fully considered in PSS design, it's possible that the service technician cannot do the job. For example, I don't know, they may have limitation in work hours, or they are maybe located in too far location, things like that. So the thing is, this kind of knowledge base, based on the previous cases, indicate, please do consider these interdependencies and take those effectively into account in the design. So that's the sort of message of this slide, and designers should consider that kind of thing in designing phase. No? What else?
Actually, what?
Yeah.
So by using these tools, the
Yep.
unrealized part will be reduced.
Yeah, that's one big purpose. Yes. Yeah. Yes, exactly. So that's why I picked up that research study result at the beginning of this lecture. So avoid unrealized services, and so realize the services well combined with the product components. So these are the messages. Good, thank you for a question. More question? Okay, no, yes?
So in each of those cells, what do resource use, availability, and outcome mean?
Okay, so resource use, outcome, affordability, etc. are attributes for the PSS. Okay, so meaning that, yeah, let's say using the, yes. Continuing the previous example, in that example, what is affected in the PSS level, overall level, is an outcome, because in that particular case, some services can't be executed. Therefore, a certain outcome is not realized on the PSS level. And then it may be affordability in another case of this kind. Those PSS design parameters, or high-level descriptions, are also coming from the cases that we found in scientific papers. So that's what we also categorized those aspects on the PSS level into a quite small number of classes. I think there were only 5 or so. So that you as a designer can only see this high-level description, abstract description.
So you mean those for example, outcome and affordability are the underutilized areas?
Yeah, you can say that as the PSS features. Huh? Okay. Help necessary. It's frozen. Okay. Any more question in the meantime? What's next? Yep. Thank you. Perfect. So some information of the Excel file that you get access to. It's a simple spreadsheet, and then if you open one sheet, then you will see this kind of matrix, because you have a specific PSS case, and therefore you should be able to describe service design parameter instances. Okay, instances mean that specific design parameters from the service point of view of your PSS offering. Okay, so that's one thing to do here in this column, and then moving to the next column, it's a description of the class. So what you should do, there are options. It's a pull-down menu, and if you, for example, say service logs as one service design parameter instance of your PSS, then you should choose one class that is information transferability of the service. Okay, and another example is customer training as service design parameter instance. Then you should choose capability of the service design parameter class. The same task applies to the product. Okay, you describe the product design parameter instances, the specific concrete design parameters of the product in your PSS, and then choose the design parameter class, one of them. No? one of the alternatives that you see from the Excel file. Once you have chosen the service design parameter class and product design parameter class, then the possible relations between the product and service will be indicated in this matrix. This is a sort of simple software developed for academic purpose, so it may not run perfect, but the idea is you describe the parameter instances, and then you are to choose class parameter, and then the according to the 42 cases behind this matrix, the interdependencies are suggested. That's a sort of automatic process. And what you should get from this matrix is, so now here, okay, so this parameter and this parameter has an interdependence. And then you as a designer should consider the possibility of using that interdependence. Either replacing the effort of the product with the effort of the service, or making a better balance between the two. Okay? So far, is it clear? Okay. Then I will give an application example, which we worked with a company producing elevators that are, those elevators are special ones because they are used only in the towers for windmills. It's very specific one. Business purpose, quite special elevators. And the company wanted to optimize the product and service throughout the elevator life cycle, right? So the procedure we applied for this case is this. The core part is step 2, 3, and 4. So getting the critical design parameters of the products and services. Okay, that's step 2. And then step 3 is find potential interdependencies between the product and service design parameters by using the knowledge base that I have explained. And step 4 is for the generating improvements based on the interdependencies found in the previous step. Step 1 and step 5 are meant for an assessment of the current offering at step 1 and improvement offering at step 5. And then in this specific study, we used life cycle assessment, and we measured CO2 emission against the status quo and the improvement offering. Okay. And first, this slide shows the result of the life cycle assessment, CO2 emission. We calculated CO2 emission of the elevator usage for the wind turbine tower, and we found that the use phase of the elevator emits 82% of the total CO2 emission of the life cycle. And interestingly, the emission 82% comes from the not through the electricity used for moving the elevator cargoes, but because of the stoppage of the wind turbine when the maintenance takes place for this elevator. Okay, so there are maintenance activities for this elevator. That's the service by this elevator manufacturer. And when maintenance takes place, because of the safety regulation, windmill must be stopped. Okay. In that situation, renewable energy is not produced, right? So renewable energy that can be produced through the wind turbine can't be produced because the windmills don't rotate during the maintenance process. In the assessment scenario, we assumed that the lack of producing such renewable energy is compensated by the other means, such as fire plant, electricity production, and so on, which is emitting much more CO2, as you know. No? So that was a little bit the background of the calculation. Anyway, what we got as one important message is the time for doing maintenance for the elevators is so important, because if the time is shortened, then the windmills are operated longer, and thereby CO2 emission as a whole in the system will be decreased. Okay, so that's the sort of logic, and therefore we learned from the assessment of this case that this PSS, in terms of the PSS design parameter, availability at the high level is very important. Availability of is the very important parameter. Then we used the matrix. We first searched where availability exists in the matrix. Okay, as you see in the yellow marks, and we asked experts who are designers of this product and also services. And according to the experts, these three red ones are relevant in this specific case, right? It is natural because this matrix and the knowledge base are built based on a number of different cases. And that includes a number of sectors coming from obviously outside the elevator service, okay? Pumps and forklifts and engines and so on. So this naturally happens. So the experts say that these are the three relevant interdependencies. So now designers looked into the product design parameter classes and service design parameter classes. And we asked again the experts of the product and service of this offering, and what are product design parameter instances of this elevator? For example, actual lifetime, component durability, internal sensor system availability, and so on. We did the same for the service design parameter instances. So then, as this table shows, we combined the product design parameter instances and service design parameter instances, and designers came up with improvement ideas. And one of them was reducing the time for performing the maintenance through, I think, through improving the service protocol, and also using the predictive maintenance. Then experts said that currently the maintenance typically takes 2.5 hours, but that can be reduced down to 1, and thereby the maintenance time can be significantly reduced, and hence the CO2 emission of the system can be reduced accordingly. And then, by the way, very much significantly in this case. There is another idea came up with this combination and also brainstorming. That one was product life extension. Okay. So, so meaning that in the previous this application, designers received the output from the knowledge base, and they brainstormed, and they came up with solutions, and then lifecycle assessment was performed for the improvement solutions, and the results are shown in this graph. Okay. Any question regarding this application? So now, I would like to help you with the your project work. So my suggestion is basically use the step 2, step 3, and step 4 using the knowledge base, using the Excel file you have access to. And here, as the starting point, critical design parameters of products and services. I suppose you have some useful outputs from FMEA and QFD. No? So, of course, you are recommended to use the outputs from the other methods. And then once you have these critical design parameters, then you should move to step 3, right? And there are different ways to perform step 3. And the way I explained with the elevator example is a little bit different from what is recommended here. I think this is easier to execute, so that's why I'm showing the this way to perform step 3 here. So, first, you capture important product and service design parameter instances. This was actually step 2, no? Okay, and then identify the class parameter for each instance parameter. Okay, using the Excel sheet. You type in your instance, and then in the next column you choose class parameter. Okay, and then the knowledge base will automatically tell you whether or not there are interdependency between specific combination or no combination, no interdependency. Okay. Then you get the dependencies of the product and service, and then moving to step 4. Suppose you have obtained interdependencies between the product and services. Investigate whether or not the registered cases are useful to your own PSS case. The registered cases are described on a different sheet. It's quite a big sheet, but you can read them. And actually, the 11 examples that I have explained are from those cases. So you could use the 11 cases as a reference also. And then if you find some sort of transferability, meaning that if you think that you can use some of the ideas of the specific case to your own case, then do that and generate ideas for improvement through analogy, okay? And thirdly, just describe your improvement options, right? Any question regarding what to do? So basically, as I said at the beginning of this lecture, you are now in the phase of converging design improvement for your PSS offering, and PSS interdependency matrix will help you look into specific connections between the products and services, okay? And there are full of cases that may be useful for your specific PSS case, okay? So this is the message. And I should also give some remarks. One remark is related to the second bullet point, meaning the knowledge base is not complete, right? So as I said, it's based on 42 cases that we found in scientific literature. And we don't argue that matrix is complete. So meaning that in the future, some people may find another interdependency. So just be aware of that limitation. And also, you may find an interdependency outside the matrix even. So for example, you may find a service design parameter instance that doesn't belong to any of the classes, and also that applies to another, and even in that case, you may find interdependency between the two parameter instances. It's also possible, huh? But the use of the knowledge base is recommended because we think that is helpful for you to sort of decrease the design space that you need to explore. So as I said earlier today, it's very much time consuming and inefficient to explore the possible dependency between all the products parameters and service parameters on the instance level. So that's why you are recommended to do that same reasoning on the class level, okay? So that's the message. Yep, okay. With that, I'm happy to take any question that you may have. Okay, so clear.